Okay, so we've got two more types of factoring to look at. Remember, on Monday, you guys are going to have a quiz on factoring only. I'll also be giving you your review assignment today to start working on because you have your first big exam, your first unit exam on Wednesday. So Monday, you'll have the quiz. You'll have some time to work on that review assignment, maybe work on some of the other assignments that need to be handed in if you haven't done so already. Tuesday, we'll go through the quiz, and then you'll have more time to get ready for that test, which is on Wednesday. Yes, ma'am. I did. Yeah, it should have been Chloe. Thanks for letting me know. Okay, so two more types of factoring that we are going to learn. So as introduction into the first type, when you multiply the sum and difference of two terms, the product of them will always be difference of squares. So what this means, like the x plus 2 and the x minus 2, it's the sum of x plus 2 and the difference between x and 2. That's the sum and difference of terms. So let's see what happens when we multiply this out. We'll use a distributive property. So the x in the first bracket times the x plus 2 in the second, the positive 2 in the first, and I'm sorry, that should have been x minus 2 in the second, not x plus 2, so we'll fix that. The second bracket is x minus 2. So when you multiply these out, x times x is x squared. X times negative 2 is minus 2x. Positive 2 times x is positive 2x. And 2 times negative 2 is negative 4. Can we simplify that, Cheney? What about them? No, you're actually adding and subtracting. We've already done our multiplying. What would Brock say? That's right. They cancel each other out. So you're left with x squared minus 4, which we call a difference of squares because of three things. There's two terms there. It's the difference of two squares. Okay, Brooklyn? Take out your earbud, please. It's the difference between two perfect squares. The first term is a perfect square. The square root of x squared is x. And the second term is 4. The square root of that is 2. So that is known as a difference of squares. Okay? Now, remember, we multiplied x plus 2 by x minus 2 to get x squared minus 4. That means if we factor x squared minus 4, it would be what we started with, x plus 2 and x minus 2. Those are the factors of x squared minus 4. Because we multiplied them out to get the x squared minus 4, so if you go backwards by factoring them, you get what you started with. Okay, so the next one is similar. It's the product of the sum and difference of two terms. We will multiply these together, again, by using the distribution method, distributive property. So a times a is a squared. A times positive 5 is positive 5a. Negative 5 times a is minus 5a. And negative 5 times 5 is minus 25. Once again, those middle two terms will cancel. 5a take away 5a is 0. You're left with a squared minus 25, which is a difference of squares. Because there's two terms, minus sign in between, both terms are perfect squares. And also, we multiplied a minus 5 by a plus 5 to get a squared minus 25. So if we factor that, the factors will be a minus 5 and a plus 5. The factors. Okay? What would we do for example 3? Brooklyn, put your phone away. Put it away. What would we do? If I want to multiply u plus v by u minus v, what would we do? Use the distributive property. Yes, that is the first step. See, Jan, I told you she was smart. You said she wasn't. Told you. Okay, so u times u is u squared. Now u times negative v is negative uv, and v times u is positive vu or positive uv. And v times negative v is minus v squared. So again, the negative uv and the positive uv cancel each other out. And you're left with u squared minus v squared, which once again is a difference of squares. You've got two terms, there's a minus sign in between, and both terms are perfect squares. So this is what you get when you multiply out u plus v and u minus v. So that would mean then that the factors of u squared minus v squared are u plus v and u minus v. So u squared minus v squared is a difference of squares, and when you factor, you get u plus v and u minus v. So if you look at these, to factor a difference of squares, it's really quite easy, right? So what we're looking at is if you start with x squared minus 4, which is a difference of squares because it's a binomial, there's a minus sign in between, that's where the word difference comes from, and both terms are perfect squares. When you factor a difference of squares, you're always going to get two binomial factors. Excuse me. The square root of x squared is x, so that's where that x and that x comes from. The square root of 4 is 2, that's where those 2's come from. And then you make one a plus, one a minus, an x plus 2, an x minus 2. There's your factors. Okay, Peyton? Same thing with a squared minus 25. So if we look at this statement right here, a squared minus 25 is a difference of squares. So when you factor a difference of squares, you get two binomial factors. The square root of a squared is a, that goes there and there in the position 1 of each binomial. The square root of 25 is 5, so that's where those 5's come from. One's a plus, one's a minus, or one's a minus, one's a plus. The order doesn't matter. Do I need you to put your phone on my desk? Why is it so hard to stay off of it? Put it inside your binder, okay? Please and thank you. So u squared minus v squared, difference of squares. The square root of u squared is u, that is where those u's come from. The square root of v squared is v, that's where those v's come from. One's a plus, one's a minus. Once you recognize that you have difference of squares, they are really easy to factor, really easy. You just have to make sure that they are difference of squares, which means, again, you have a binomial, there's a minus sign in between, and both terms are perfect squares. So, excuse me, x squared minus 9, that is difference of squares because it's a binomial, both terms are perfect squares, and you have a minus sign in between. When you factor a difference of squares, you'll get two binomial factors. The square root of x squared is x, so those are the first terms of the binomial. The square root of 9 is 3. That's the second term of each binomial. One's a plus, one's a minus. There's your factors. You see, if you check this, which we've been doing almost every time using distributive property, you should get what you start with. X times x is x squared. X times negative 3 is negative 3x. Positive 3 times x is positive 3x. And 3 times negative 3 is negative 9. The minus 3x plus 3x cancels. You'll get x squared minus 9. What you started with, we've just shown that our factors are correct. We've just shown that. Okay? Question 2 is difference of squares because you have a binomial, both terms are perfect squares, and then there's a minus sign in between. So once you recognize that, they're easy to factor. The square root of x squared is x. The square root of 16 is 4. One's a plus, one's a minus. There's your factors. And you can multiply them out to check to make sure. Peyton, put your phone in your binder, please. Okay, number 3. This is difference of squares. It's a binomial, both terms are perfect squares, and there is a minus sign in between. So that means the factors will be binomial factors. And the square root of 4t squared is 2t. You take the square root of both the 4 and the t squared. The square root of 9 is 3. One's a plus, one's a minus. There's your factors. And again, you can always check by multiplying to make sure. Question 4 is difference of squares. It's a binomial, minus sign in between, and both terms are perfect squares. So that means we can factor it as a difference of squares. And the factors, once again, are two binomial factors. The square root of 25a squared b squared is 5ab. We take the square root of the 25 of the a squared and the b squared. And the square root of 1 is 1. One's a plus, one's a minus. There's your factors. Once you recognize that it's difference of squares, they are very easy to factor. Question 5. As it sits right there, that is not difference of squares because neither 8 nor 2 is a perfect square. However, remember, the first thing you should always look for is a common factor. There is a common factor here of 2a. That's your first factor. To get the other factor, you divide both terms by 2a, which will give us 4a squared minus 1. That last term of 2a, when you divide by itself, you'll get a 1 there. Remember, you got to be able to multiply it out to get what you start with. And now, that binomial inside the brackets, that is difference of squares. By taking out a common factor of 2a, which you always look for first, we're left with difference of squares. The square root of 4a squared is 2a. The square root of 1 is 1. One's a plus, one's a minus. There's your factors. Question 6, the way it stands right now, is not difference of squares. Because you don't have a minus sign in between the two terms. But what we can do is we can just rearrange them. Put the positive 25d squared first and the minus 16c squared second. Now it is difference of squares because both terms are perfect squares and there's a minus sign in between. So again, if you have a difference of squares and you're factoring it, you'll get two binomial factors. The square root of 25d squared is 5d. Take the square root of both the 25 and the d squared. The square root of 16c squared is 4c. One's a plus, one's a minus. There's your factors. 7 is not difference of squares because there's a plus sign in between the terms. You cannot factor a sum of squares, only difference of squares. And there's no minus sign between the terms, so it's not difference of squares. It's sum of squares, which cannot be factored. Question 8. Those aren't difference of squares right now, but remember the first thing you always look for is a common factor. And there's a common factor here of 7g cubed. And if you take it out, you'll be left with 8 squared minus 4g squared. And 8 squared minus 4g squared is difference of squares. The square root of h squared is h. The square root of 4g squared is 2g. One's a plus, one's a minus. There's your factors. Okay? So once you recognize that a polynomial is difference of squares, they are really easy to factor. And remember, you can always multiply out to make sure you get what you started with. So for these ones, again, we're going to factor each if possible. The first one, 49a squared, take away 25 is difference of squares. Because you've got two terms, there's a minus sign in between, and both terms are perfect squares. The square root of 49a squared is 7a. The square root of 25 is 5. One's a plus, one's a minus. There's your factors. Question B, you have 125 x squared minus 40y squared. So as those stand, they are not difference of squares. However, both of these terms is divisible by 5. There's a common factor of 5 there. And when you take out a common factor of 5, you'll get 25x squared minus 8y squared. And unfortunately, that is not difference of squares because 8 is not a perfect square. Just doesn't mean we can't do any more factoring, but we still factored out a common factor of 5. So we did factor. The only thing that's stopping us from factoring what's inside the brackets as a difference of squares, though, is the fact that 8 is not a perfect square. But we still factored. Question C, you have 9p squared q squared minus 25. That is difference of squares. The square root of 9p squared q squared is 3pq. Square root of 25 is 5. One's a plus, one's a minus. There's your factors. All right. Did you not get all that, Jam? There you go. Hurry up, because you're boring Sophia. She's so bored, she's yawning. Okay. So let's see what this last type of factoring is. It's called factoring what's known as a perfect square trinomial. So when you square a binomial, the result is a perfect square trinomial. Remember, when you square something, it means multiplying it by itself. So x plus 2 all squared means x plus 2 times x plus 2. And we could do that using distributive property. Which gives us x squared plus 2x plus another 2x plus a 4, or x squared plus 4x plus 4. And remember, we also had that shortcut for squaring a binomial, which was squaring the first term. If you square the x, you'll get the x squared. When you square the last term, the 2, that gives you the plus 4 at the end. To get that middle term of 4x, you'd multiply the x and the 2 together and double. We did that. Okay? But we're saying that this x squared plus 4x plus 4 is a perfect square trinomial, which means you can take the square root of it. Who can tell me what the square root of that is? Yes? No. Remember, this is the same thing as x plus 2 all squared. We took x plus 2 and squared it to get x squared plus 4x plus 4. What's the square root of x plus 2 all squared? It'll just be x plus 2. If you take the square root of this, it'll cancel with the square, and you're left with x plus 2. Which means if you take the square root of x squared plus 4x plus 4, the answer is also x plus 2. They are the same thing. They're just different forms. Right? We've got the expanded form, a sum of terms, and we've got the product of two factors. They are the same. So, to factor a perfect square trinomial, again, it's really easy. Once you recognize that it's a perfect square trinomial, it's really easy to factor. So, when you have a perfect square trinomial and you factor it, the result is a binomial squared. These are the characteristics for a perfect square trinomial. The first and last terms must be perfect squares. So, you've got the x squared, there's your first term, that is a perfect square, as well as the last term, positive 4. is a perfect square. So that's what these first two bullets say. But the other part is the middle term must be twice the product of the square root of the first term and the square root of the last term. You see the square root of x squared is x, the square root of 4 is 2. Those are the square roots. The middle term must be twice the product of those square roots. So again, x times 2 is 2x, and when you double it for twice the product, that gives you your 4x. Once you recognize that a trinomial is a perfect square trinomial, it makes it really easy to factor. The square root of x squared is x, so that's where that x came from. The square root of the last number 4 is 2, that's where the 2 came from. And to know whether it's a plus or a minus between them, look at the middle term. Because it's a positive 4x, that's why it's a plus between those two terms. Now, we factored trinomials before using inspection, right? By finding two numbers that multiply to get the last number, add to get the middle number. And that'll work for these as well. But recognizing a perfect square trinomial can be quite helpful when you get really, really big ones to factor. When you get really, really big numbers that you need to factor, really big numbers in trinomials, usually it means it's a perfect square trinomial. But let's do some practice. This first one looks like it might be a perfect square trinomial because the first and last terms are perfect squares. But that's only the first step to checking. There's another step. So to do that, take the square root of the x squared, that's x. Take the square root of 9, that's 3. Remember, the other thing that must happen is when you take the square root of those two terms, if you multiply them together and double, you must get the middle term, and you do. X times 3 is 3x, double does give you 6x. So because that middle term is 6x, this is a perfect square trinomial, and because it's a positive 6x, the factors are x plus 3 squared, which is the same as x plus 3 times x plus 3. And if you did it the old way by finding two numbers that multiply to get 9 and add to get 6, they'd be positive 3 and positive 3. You'd write x plus 3 in the first bracket, x plus 3 in the second bracket, which is the same as x plus 3 all squared. So you could have factored that one the way we did before. Same thing with number 2. If you look at it, you'll recognize that the first and last terms are perfect squares. So it might be a perfect square trinomial. The square root of y squared is y, the square root of 25 is 5. But remember, you need to multiply those together and double, and if it gives you the middle term, then it is a perfect square trinomial. And it does, because 5 times y is 5y, doubled is 10y. So this is a perfect square trinomial because it's a positive 10y. It's y plus 5 all squared. The factors are y plus 5 and y plus 5. If you did it the old way, you'd be looking for two numbers that multiply to get positive 25, add to get positive 10, plus 5 and plus 5. So it works. Question 3. Looks like it might be a perfect square trinomial because the first term is a perfect square. The square root of a squared is a. The last term is also a perfect square. The square root of 49 is 7. But then you also have to multiply them together and double and get the middle term, which you do. 8 times 7 is 7a, doubled is 14a. But because it's a minus 14a, the factors are a minus 7 all squared. A minus 7, a minus 7. And again, if you did this the old way, two numbers that multiply to get positive 49, add to get negative 14 are negative 7 and negative 7. Number 4 right now is not a perfect square trinomial because neither 2x squared nor 242 are perfect squares. However, remember, the first thing you always look for is a common factor. And there is a common factor of 2 that you would take out first. So that gives you x squared minus 22x plus 121 inside the bracket. And that might be a perfect square trinomial because the square root of x squared is x, the square root of 121 is 11. If you multiply these together and double, you do get 22x. And because it's a minus 22x, the factors are x minus 11 all squared. Don't forget about the common factor at the start though, right? That's one of your factors. Question 5, there is a common factor of 3 there to take out as a starting point. 3 is one of the factors. To get the factor inside the bracket, we divide every term by 3. And, well, actually, let's change that up. Because this looks like it might be a perfect square trinomial, because the square root of t squared is t, the square root of 16 is 4, and if you multiply those two together and double, you do get 8t. And because it's a minus 8t, it's t minus 4 all squared. Remember, that binomial is squared. Okay? Now, question 6 is not a perfect square trinomial because you can't take the square root of the last term. There is no square root for a negative number. So this is not a perfect square trinomial. Because there's no square root of negative 36. Cannot take the root of a negative number. But the next one looks like it might be, because the first and last terms are perfect squares. The square root of a squared is a. The square root of 36 is 6. But you see here, when you multiply them together and double, you get 12a, not 13a. It's not a perfect square trinomial. Right? A times 6 times 2 is 12a, not 13a. But it doesn't mean it can't be factored. It's just not a perfect square trinomial. And in fact, this one can be factored. Most of the time when we factor a trinomial, there's two binomial factors. The front terms have to multiply together to get a squared. And the last numbers multiply to get positive 36 and add to get negative 13. That would be a minus 9 and a minus 4. Negative 9 times negative 4 is positive 36. And when you add negative 9 and negative 4 together, you do get negative 13. Remember, I said at the start that where this type of factoring is really helpful is when you get trinomials with bigger numbers like these last two. Okay? Without knowing what we've learned about perfect square trinomials, you'd have to use that guess and check method we talked about the last couple days. However, you recognize that the 4m squared is a perfect square and the 25 is as well. So you're going to check for a perfect square trinomial. The square root of 4m squared is 2m. The square root of 25 is 5. If you multiply these two together, you'll get 10m, and you double, you do get the 20m. And because it's a positive 20m, the factors are 2m plus 5 all squared. If you did this the way we did in the last 2 days, you would get 2m plus 5 and 2m plus 5. But this is a lot quicker than the way we did it the last 2 days. And you'd have to do it that way because, remember, you've got that number in front of the m squared that cannot be taken out as a common factor. Same thing with number 9. Those are some big numbers to deal with. However, you recognize that the first and last terms are perfect squares. The square root of 16a squared is 4a. The square root of 9b squared is 3b. But that's only the first part. The second part is, if you multiply these two together and double, you must get the middle term, and you do. 4a times 3b is 12ab. Doubled is 24ab. And because it's a minus 24ab, the factors will be 4a take away 3b all squared. Again, without knowing about this perfect square trinomial, you'd have to do it the way we spent the last 2 days, that guess and check. And you'd get 4a minus 3b, 4a minus 3b. But this was a lot quicker. Okay? So checking these last ones. Should recognize that in this case, the first and last terms are perfect squares. The square root of x squared is x. The square root of 144 is 12. If you multiply those two together and double, you do get 24x. So it'd be x minus 12 all squared. Question B is not a perfect square trinomial because you cannot take the square root of negative 81. So we saw one like this already. You cannot take the square root of negative 81, so it's not a perfect square trinomial. Are there two numbers, though, that multiply to get negative 81 and add to get negative 18? And there are not. I mean, 9 times 9 is 81, but they have to have different signs to get a negative 81 at the end. So a positive 9 and a negative 9 do multiply to get negative 81, but when you add those together, you get 0, not negative 18y. Okay? There are no factors for this one. Sometimes that happens, but remember, on a quiz or a test, if you're asked to factor, they will be factorable. This last one is not a perfect square trinomial as it stands right now because you can't take the square root of 3 or 48. But there is a common factor of 3 we could take out. And this might be a perfect square trinomial because the square root of b squared is b, the square root of 16 is 4, and if you multiply those two together and double, you will get that middle term of 8b. And because it's a positive 8b, it'll be b plus 4 all squared. But don't forget about the common factor. That's one of your factors, so it has to be included. Okay? So there's an assignment there to work on. Yep. I wasn't going to, but you asked. Okay, so this assignment needs to be handed in. I want to get the review